And in this video, we're going to go over the review for the final exam, which is on Thursday, May the 5th. Starts at 2:45, ends at 4:45 p.m. in the afternoon. What's on this review sheet will be similar to what will be on your final exam. Also, you will have a help sheet to assist you with some of the problems that will be on the final exam. So we're going to start off with problem number 1. And in this case here, we're going to solve for x. And in this case, we got x over 25 is equal to 10 over 50. X over 25 is equal to 10 over 50. So I'm going to do this on a blank sheet. Okay. Now, in this case here, all we have to do is just simply do some cross multiplication in order to solve this proportion. So if I do x times 50, that would be 50x. And that's equal to 25 times 10. That would be 250. So I had the equation 50x is equal to 250. And then to solve for x, I'm multiplying by 50. So I need to divide both sides by 50. And in this case, I'll end up with x equaling the 5. Okay. So that's problem number 1. All right, number 2. I bring this sheet back up. Find the best buy based on price per unit for cereal. A is a 13-ounce bar, a 13-ounce size for $3.59, or 28-ounce size for $5.69, or a 34-ounce size for $6.19. So basically, all we have to do there for each one of them is take the price and divide that by the number of ounces. That would give us the price per ounce in this case. Okay, so let's see, $3.59. We're going to divide that by the 13-ounce size of cereal. So we divide that by 13. Now here we have to round this up to 2 decimal places since we're dealing with money amounts here in this case. So clear this out. In this case here, we got 3.59 divided by 3. And this will be, I'm sorry, 3.59 divided by 13. And to 2 decimal places, this will be approximately 28 cents. All right, so this would be on average 28 cents per ounce for the first one. The second one is 28-ounce size for $5.69. So we do $5.69 divided by 28. And this will give us to 2 decimal places 0.20. So we're dealing with 20 cents per ounce here for $5.69 for $5.69 for a 28-ounce size of cereal. And then the third one, C, which was a 34-ounce size of cereal for $6.19. So we have to do $6.19 divided by the 34 ounces. That would give us the price per ounce here. So $6.19 divided by 34. This will be to 2 decimal places 0.18 or 18 cents per ounce. So in this case here, the lowest cost per unit is the better buy or the best buy. So in this case here, 18 cents is lower than 20 cents and lower than 28 cents. So that means that $6.19, the 34-ounce box of cereal for $6.19 is the best buy. Okay. All right, number 3 is to express each of the following as a percent. So in part A, we got 192.9, and part B is 4/5. All right, so let's start with the 192.9. And I want to convert that to a percent. All right, so going from a decimal to a percent, you always move your decimal point 2 places to the right. So wherever that decimal point is, you'll move it 2 places. So here I'm going to move this decimal point 1, 2. And here I need to add a 0 behind it. So that means 192.9 as a percent would be 192.90 or 19,290. And then we add the percent sign. Okay. And by the way, this is part A. Part B is a fraction, 4/5. Now, 4/5 you have to convert to a decimal and then change your decimal to a percent. That's one way of doing it. Another way you can do this is, since percent means per 100, what I would do here is find out what this missing number is. And that number will be over 100, and use that and write it as a percent. Okay, because percent means per 100. So 100 will be my denominator. Now to get from 5 to 100, I need to find out how many times 5 goes into 100. And that will go 20 times. So that means I need to multiply the numerator and the denominator by 20. So that means 4 times 20 will be 80. And 80 over 100, I can easily write that as a percent. 80%. Now, if you want to, you can do 4 divided by 5. That will give you 0.8, but then you'll have to take that decimal point in 0.8 and then move it 2 places to the right and include a 0. You'll get 80%. Okay. All right, number 4 is to convert each of the following to a decimal. Starting with part A, that's 13%. Now 13%, to change that to a decimal, we drop the percent sign and move the decimal point, which is in this case, since it's a whole number, the decimal point is understood to be behind the last digit. We move it 2 places to the left. So that means if I move this 2 places to the left, that decimal point will be in front of the 1. So 13% as a decimal will be 0.13. Okay. All right, part B. Now here we have a fractional percent, which is in this case 16 2/3%. All right. Now for 16 2/3%, of course, we're going to have to drop the percent sign. Okay. Now that 16 2/3 will be divided by 100. But of course, the reciprocal of 100 will be 1 over 100. So I'm going to multiply 16 2/3 times 1 over 100, since I know percent means per 100. Now let's convert 16 2/3 to a improper fraction by doing 3 times 16, that's 48 times 2, which is 50 over 3 times 1 over 100. Now in this case here, I can do some cross dividing, because I know 50 is a multiple, well, 50 and 100, they're multiples of 50. So 50 goes into itself 1 time, and 50 goes into 100 2 times. And then multiply numerator times numerator and denominator times denominator. So 1 times 1 will be 1, divided by 3 times 2, which is 6. So in this case here, I'll have 1/6 as the, actually it has to be a decimal. I apologize. Not as a fraction, as a decimal. But it's good to know that you can change it to a decimal. Let's see, I'm gonna bring the 16.2, let's see, 2 divided by 3. That's gonna be 0.6 repeating percent, because as you can see, the 6's repeat. Now let's change this to a decimal by dropping the percent sign and moving that decimal point 2 places to the left. So this will end up being 0.166 repeating. Okay, this is the decimal we're looking for, not the fraction. So here, omit this. Okay, well, it's a good way to know that you can change a percent to a fraction, but here they're asking for the decimal. And this will be at 0.166 with the 6 repeating. Okay, problem number 5, and I will put that right here. And it says here that Gail received a 5% raise last year. If her salary is now $17,535, what was her salary last year? So we're looking for the salary that she was, the amount that she received as her salary last year. So we're going to let X equal last year's salary. X will be equal to last year's salary. Now, we're told that she got a 5% raise. So that means her salary from last year, that's X, plus the 5% raise, which was 5% of the salary that she got from last year. Now, if you recall 5% as a decimal, you can take the 5 and divide that by 100. Now, I'll give you 0.05. So it'd be 0.05 times last year's salary. That would be equal to her salary right now, $17,535. Now we have our equation that we can easily solve for X. Well, this X has the understood coefficient of 1. If I add 1 plus the 0.05, that would be 1.05. So I have 1.05X equal to 17,535. And then to solve this equation for X, I'll divide both sides by 1.05. So that means X is equal to, if I take 17,535, divide that by 1.05, that'd be 16,700. So her salary last year was $16,700. Okay. All right, number 6 is to solve the equation. And in this case, we got 2x plus 7 is equal to 2 times the quantity x plus 7. So in this case here, the left side, we just go ahead and bring that down. The right side, we need to use the distributive property. That means I have to do 2 times x. That's going to be 2x plus 2 times 7, which is 14. So here I got 2x plus 7 is equal to 2x plus 14. Now watch what happens when I subtract 2x on both sides. The 2x's are gone on the left side. I'll be left with 7. and the two X's are gone on the right side, I'd be left with 14. 7 equals to 14 is a false statement because 7 does not equal to 14. So when you get a false statement like that in an equation, that means you have no solution. Now, don't think for a moment on the final exam you're going to get an equation with an answer of no solution, okay? Because you'll be able to solve an equation with a solution provided. So do be aware of that. This is just one of those cases where it happens to be no solution. All right, number 7. All right, in problem number 7, it says, for a particular event, 736 tickets were sold for a total of $4,652. If students paid $5 per ticket and non-students paid $8 per ticket, how many student tickets were sold? Okay, so in this case, we're trying to find out the number of student tickets that were sold. So I'm going to let some variable X be the number of student tickets. So I'm just going to let X be student. All right, and we have 736 tickets that were sold. So if X is the number of student tickets sold, then the number of non-student tickets that were sold will have to be this expression, 736 minus X, because we have to subtract the number of student tickets from the total number of tickets that were sold. And that will give us the number of non-student tickets. And we are told that students paid $5 per ticket. So if X is the number of students, then the cost for each student ticket is $5 times the number of students that bought the ticket. Plus, non-student tickets were $8 each. So it'd be 8 times the number of non-student tickets, which is 736 minus X. And that's going to be equal to the total, which is $4,652. So this is our equation. Okay, so now bring on the 5X and then distribute the 8 over 736 minus 8. So it'll be 8 times 736, which is 5,888. Minus 8 times X, which is 8X, is equal to 4652. Now, combined like terms, 5X minus 8X is negative 3X plus 5,888. That's equal to 4652. And then subtract 5888 on both sides. So that means we're going to have negative 3X is equal to, let's see, 4652 minus 5888 will give me a negative 1,236. And then finally divide both sides of this equation by negative 3, and you will get X to be equal to 412. Now, what was X? We let X be the number of student tickets here. And that is exactly what we have here. So X is 412. That means there were 412 student tickets sold. Now, if they ask for the number of non-student tickets that were sold, then you'll take that 412 and subtract that from the 736. And that would give you the number of non-student tickets that were sold. Okay? So do pay close attention to what they ask for in a problem such as this. Okay, that's problem number 7. All right, number 8 is finding the X-intercept and the Y-intercept for the equation Y is equal to 17 X minus 34. So our equation in this case is Y is equal to 17X minus 34. And we're going to find first the X-intercept. You always, in this case, let Y equal to 0 and solve for X when you're finding the X-intercept. So here we're going to let this Y be equal to 0. So the 0 is equal to 17X minus 34. And then to get 17X by itself, we add 34 to both sides. So that means I'm going to have 17X equaling to 34. And then divide both sides by 17 to get X is equal to 2. So the X-intercept is going to be the ordered pair to 0. Because keep in mind, X-intercepts and Y-intercepts are always going to be ordered pairs. And now for the Y-intercept. Anytime you find the Y-intercept, you always let X equal to 0 and solve for Y. So using Y equals 17X minus 34, we substitute our X with 0. So I have Y equals 17 times 0 minus 34. 17 times 0 is 0. 0 minus 34 equals negative 34. So the Y-intercept is the point 0, negative 34. Okay. All right, so that's problem number 8. All right, problem number 9. Problem number 9 deals with a system of equations here. The owner of a 4,000-gallon oil truck loads the truck with gasoline and kerosene. The profit on each gallon of gasoline is 12 cents, and on each gallon of kerosene, it is 16 cents. How many gallons of each fuel did the owner load if the profit was $520? All right, so we have two equations that we're going to have to set up. One is the number of gallons of gasoline and the number of gallons of kerosene equaling the 4,000. So here I'm going to let X be the number of gallons of gasoline, and Y will be the number of gallons of kerosene. And we know that the number of gallons of gasoline plus the number of gallons of kerosene has to equal to 4,000. So one equation is X plus Y is equal to 4,000. Now here's the other equation, the profit. Okay. There was the profit was 12 cents per gallon of gasoline. So if that's the case, 12 cents as a decimal will be 0.12 times the number of gallons of gasoline, which is X, plus, and the number of gallons, well, the profit was 16 cents per gallon for kerosene. So that would be 0.16 times the number of gallons of kerosene. That's Y. And that will total out to be the total profit of 520. So here's my second equation, 0.12X plus 0.16Y equaling to 520. Now we're going to use this to solve for X and for Y. So we want to find out how many gallons of each fuel did the owner load if the profit was $520. All right, one method I can use is the substitution method. What I can do here is solve this equation for Y. I'm going to get Y by itself by moving the X over to the other side. So if I subtract X on both sides, here's what I'm going to have. Y is equal to 4,000 minus X. Now, here's where the substitution comes in. Since Y is equal to 4,000 minus X, I'm going to substitute Y in the second equation with 4,000 minus X. So here's what I'm going to have, 0.12X plus 0.16 times this Y will be replaced with 4,000 minus X. And that's equal to 520. And now let's simplify this. 0.12X, distribute the 0.16. Well, let's see, 0.16 times 4,000. That would be 640. And then minus 0.16 times X will be 0.16X, equaling to 520. And then combine like terms here, 0.12X minus 0.16X would be negative 0.04X plus 640, equaling to 520. And then to get the negative 0.4X by itself, we'll subtract 640 on both sides. So that means I'm going to have a negative 0.04. X is equal to, let's see, 520 minus 640. I know it's going to be negative. It'll be negative 120. And then divide both sides by negative 0.04. So that means X is equal to 2,000. And that 2,000, X is 2,000, that represents the number of gallons of gasoline. So here, this is 2,000 gallons of gasoline. And now let's find out what the number of gallons of kerosene is. Y is the number of gallons of kerosene, but notice that Y is equal to 4,000 minus X. So if I take that expression, replace the X with 2,000, I can find out the number of gallons of kerosene that will be. Subtract 2,000 from 4,000, you'll get 2,000. So this is 2,000 gallons of kerosene. All right, so to answer that question, there were 2,000 gallons of gasoline and 2,000 gallons of kerosene. Okay. All right, problem number 10. Sentinel High School was found to have the same number of students listed below. If one student is chosen from the school, what is the probability that the chosen student is a senior? Okay, so here's the table right here that's given to us. Now let's find out the total number of students here. I'm gonna add, I'll put this to the right side. I'm gonna add 472 to 548 to 549 to 431. That would give us 2,000. So the total number of students here is 2,000. And we want the probability that the chosen student is a senior. So here we got 431 seniors out of a total of 2,000. So the probability of selecting a senior randomly, it would be 431 over the total number of students, which I did mention was 2,000. Okay. And we'll leave this as a simplified fraction. Okay. And we can't simplify that any further. All right, so that's problem number 10 right there. Okay. All right, number 11. This is one of those tree diagrams that you have to do here. So here is problem number 11. A box contained 5 black balls and 4 white balls. 2 balls are drawn out of the box one by one. And in part A, you're going to create a tree diagram for this experiment if the draws were made with replacement. Okay, let's start with that. So in this case, it'll do a tree diagram, and this is going to be with replacement. That means that the balls on the first draw would go back in the box when we do the second draw. So this is with replacement. Now we're either going to draw a black ball or a white ball. So I'm going to let B be the black ball and W be the white ball. And the probability of selecting a black ball, there were 5 black balls and 4 white balls. The total number of balls would be 9. So the probability of selecting a black ball would be 5 out of the total number, which is 9. So that's 5 9ths. And the probability of selecting a white ball, there were 4 white balls out of 9. So that's 4 9ths. Okay, so now this was the first draw. This next branch represents the second draw. It's either going to be a black or a white if the first one was black. And if the first one was white, it's going to be black or white. And notice that the probability is going to be the same, because on the second draw, what we drew out, the first one will go back in the box for our second draw. So the probability of selecting a black ball on the second draw will still be 5 9ths, and drawing a white ball on the second draw will still be 4 9ths. And the same holds true here as well if the first ball was white, because that white ball is going to go back in the box. Now, these are all of our outcomes here: a black and a black, and then a black and a white and a black, and then a white and a white. So in this case, if we multiply the probabilities that are along each of these branches here, for black and a black, that would be 5 9ths times 5 9ths, which will be 25 over 81. And then for a black and a white, 5 9ths times 4 9ths. Well, 5 times 4 will be 20 over 9 times 9, that's 81. And then this next one, 4 9ths times 5 9ths for a white and a black. That's also going to be 20 over 81. And then for a white and a white, 4 9ths times 4 9ths. That will be 16 over 81. All right, so that's part A right there, drawing the tree diagram. Now part B, which I'm going to do here off to the side, they want, in this case, to find the probability of the event that the 2 balls are of the same color. So in this case here, the same color would be a black and a black and a white and a white. So the probability of selecting a black and a black or a white and a white, they're both the same color, that would be the probability of a black and a black plus the probability of a white and a white. So the probability of selecting 2 black balls was 25 over 81 plus the probability of selecting 2 white balls, that was 16 over 81. And if we add 25 over 81 to 16 over 81, that would give us 41 over 81. And that would be in its simplest form. Okay, so that's part B, finding that probability. Part C is going to be another tree diagram. This time, the draws were made without replacement. That means whatever I draw on the first ball, on the first pick, won't go back in the box when I make my second draw from that box. Okay, so that means our probabilities are going to be different. Okay. Let's see, black and a white. There are 5 black balls, so the probability of selecting a black ball is 5/9. And then the probability of selecting a white ball, that's still 4/9 because there were 4 white balls. The total number of balls was 9. Now the second draw. All right, let's look at their probabilities here. If the first ball was black, I start off with 5 black balls. That means I'm going to have 4 black balls left to draw, and I will have 8 balls left. Because on the first draw, on the first ball that I pick, that's not going back in the box. So that means I have 8 balls left. But here, if that first ball was black, that means I'm going to have 4 black balls. So that's 4 black balls out of 8. Notice that the probability has changed. So 4/8, if I reduce that, it's going to be 1/2. Now the number of white balls, even with the first ball being black, I still have 4 white balls left. So it'll be 4 out of 8 as well. That's going to be 1/2. Okay. Because I no longer have 9 balls in the box, I have 8. Now for the white ball, if the first ball was white, I'm still going to pick either a black or a white. Now, even if the first ball was white, I still have 5 black balls, but instead of 9 balls in the box, it'll be 8. So it'll be 5 out of 8. But that probability of selecting a black ball on the second draw, given that the first ball was white. Now, for the first ball being white and that second ball being white, now I'm going to have 3 white balls left instead of 4 out of 8. And notice here, if you add these probabilities along the branches, they have to equal to 1. Now let's list all of our outcomes and their probabilities. I have a black and a black, black and a white and a black, a white and a white. Let's multiply along the branches here. So I have 5/9 times 1/2, which will be 5/18. And then 5/9 times 1/2 for a black and a white, 5/9 times 1/2 again. That's still going to be 5/18. Then a white and a black, 4/9 times 5/8. Let's see here. 4 can go into itself 1 time, 4 goes to 8 2 times. So 1 times 5 will be 5/9 times 2, which is 18. And then a white and a white will be 4/9 times 3/8. And I know 4 goes into itself 1 time, 4 goes into 8 2 times. 3 goes into itself 1 time, 3 goes into 9 2 times. So this will be 1/4. Correction. 3 goes into 9 3 times. 3 times 2 would be 6. So this should be 1/6. Okay. And this does add up to 1, because if I convert 1/6 with a denominator of 18, that would have to be 3/18. Plus 5/18s, 5/18s, and 5/18s, that's 18/18 or 1/2. Okay. So now we can answer part D. Because part C was doing the tree diagram, part D is find the probability of the event that the two balls are of the same color. So in this case here, I'll build up a black and a black, or a white and a white. So it'll be a probability of a black and a black plus the probability of a white and a white. So the probability of a black and a black, that's 5/18, plus the probability of a white and a white, that's 1/6, 5/18, plus 1/6. All right, common denominator of 6 and 18 is 18. Bring this 5 over. To make that 6 18, I have to multiply the 1 times 3 to get 3. 5 18s plus 3 18s will be 8/18. If I reduce that by dividing the numerator and the denominator by 2, it'll be 4/9. So the probability of the event that the two balls are of the same color will be 4/9. So this right here represents the final answer. Let me go ahead and box that in. Or better yet, I can put this on the next line. If that's confusing, I'll do that. Okay. I said that all of that was problem number 11. All right, problem number 12 is this. A box contains 6 letters shown as traced, TRACED. What is the probability of the outcome, ARE, in that order if, and this should be 3 letters, are drawn one by one with replacement and without replacement? All right, let's start up with replacement. So that means our probability is not going to change here. So that means the probability of getting an A, since there's 6 letters in the word traced, there's only one A, so that means it's going to be 1/6. There's only one letter in the word, there's one R in the word trace, so that probability will still be 1/6. And there's still one E in the word trace, also 1/6. And this with replacement, meaning that the letters are going to go back in after the first draw, and they'll go back in after the second pick. All right, so the probability of ARE is this. We just multiply 1/6 times 1/6 times 1/6. 1 times 1 times 1 will be 1, divided by 6 times 6, 36 times 6 will be 216. So the probability of selecting ARE, if those letters are drawn one by one with replacement, would be 1/216. Okay, part B, without replacement. So that means after the first pick, the probability of drawing an A will be 1/6, but drawing an R, that means I'm not going to have 6 letters. I'm going to have 5 letters, because whatever I pick on the first draw won't go back in on the second when I make my second pick. So I'm only going to have 5. So it'll be 1/5 for a probability of selecting an R. And then the probability the denominator will drop, because now I'm going to have 4 letters to choose from instead of 6. And the probability of selecting an E would be 1/4. So now the probability of selecting an ARE in that order would be 1/6 times 1/5 times 1/4. 1 times 1 times 1 will be 1. And then 6 times 5 will be 30. 30 times 4 will be 120. So probability of selecting A, R, E in that order, if those three letters were drawn with replacement would be, without replacement would be 1 over 120. So that's problem number 12. All right, problem number 13 is this. If the probability of a child being a girl is 1/2, and the family plans to have 3 children, what are the odds against having all girls? Okay, so let's find the probability of having 3 girls. The first girl is the first child being a girl, that probability is 1/2. The second child, probability of being a girl is 1/2. And the third child, the probability of getting a girl is 1/2. And these are independent of each other. So we're going to multiply 1/2 times 1/2 times 1/2, which will give me 1/8. That's the probability of getting 3 girls if the family wants 3 children. Now, what are the odds against? Odds against 3 girls would be this: 1 minus the probability of 3 girls divided by the probability of 3 girls. Okay, that's the formula for finding odds against. 1 minus the probability of event A divided by the probability of event A. So now we're going to have 1 minus. Probability of 3 girls was 1/8 minus, 1 minus 1/8, that's the numerator, divided by the probability of 3 girls, that's also 1/8. And if you do this on the calculator, 1 minus, let's say 1 divided by 8, and then hit the math key, select number 1 for fraction. I know, that'd be 7/8 divided by 1/8. I understand I'm kind of cheating here. I'm doing that for the sake of time. All right, so if I do 7/8 times the reciprocal of 1 over 8, which is 8 over 1, it'll be 7 over 1. And we have to write this as 7 to 1. So the odds against having all girls will be 7 to 1. All right, that's problem number 13. All right, problem 14 is this. Problem number 14 is this. If the odds in favor of fast leg winning a horse race are 6 to 5, and the first place and the first prize is $99,000, what is the expected value of fast legs winnings? Okay, so odds in favor is given to you. That's 6 to 5. The probability of winning. Now, the way we do that is this. We take the first number in this ratio, which is 6. That's your numerator. That's going to be divided by the sum of those two numbers, 6 and 5. Now, had it been odds against, then we take the second number, which is that 5. That will be your numerator. And then the denominator, you'll still have to add your two numbers together. All right, so bring over the 6, add 6 and 5 together, you'll get 11. So the probability of fast leg winning would be 6 over 11. Now for the expected value. That's, of course, E is equal to the probability of fast leg winning multiplied by the prize amount. The probability of fast leg winning would be 6/11 times the prize, the first prize, which was $99,000. Okay. So if we take 6/11 times 99,000, that would give us, and I'm going to do 6 times 99,000 divided by 11. And that's going to give us 54,000. So the expected value of fast leg winning would be $54,000. Okay. All right, so that's problem number 14. All right, problem 15. A company employs 20 people whose ages are listed below. Answer the following questions from the information given on the list. And from that, you're going to draw a stem and leaf plot for the set of data. And then we'll answer part B, are more employees in their 40s or in their 50s? How many employees are younger than 30 years old? What percentage of the people are 50 years or older? All right, and here's our data set right here. So that means right off the top, we're going to need a stem and leaf plot. So part A is the stem and leaf plot. So here's our data set right here. I see the smallest is the 20s and the largest is I think the 60s, I believe, yeah. So my stems are going to go from 2 to 6. So I have a 2, 3, 4, 5, 6. Now I need to identify my stems here. I mean, my leaves here for each of those stems that I have here for the 20s. Okay, and I'm going to use different colors here to identify the numbers that are in the 20s. So here I got, in this case, I do have a 21, a 23, 24, 27, 29, and 27. So I get 6 numbers in the 20s. So in this case, I need to put these in numerical order from least to greatest. So 21 will have to go first. So I need to put a 1 to represent the leaf for the 20s. And then I got 23. So I write down a 3 for that. Then 24, write down a 4 for that. I got a couple of 27s. I have to put the 7 there twice, because I have 2 data values that are 27 and 29, and 9 goes there. Those are all the numbers that are in the 20s. Now for the 30s, in this case here, let's identify the numbers that are in the 30s. So I do have a 34. And another 34. Okay. So 34 is repeated twice. So I'm going to use the 4 as a leaf twice. All right, now, next is the 40s. So by looking at this, I have a 41, 43, 47, and that's it. So 41, 43, and 47. I need a 1 and a 3 and a 7 to represent those data values. And now for the 50s. Guess I have to use red. 51, 53, 55, 59, and another 59. All right, so we'll start with 51 first, because that's the smallest of the 50s. And then 53, then 55. And then got a couple of 59s, so I need to write down the 9 twice. And then for the 60s, I got 61, 63, 61, and 64. I got 2 61, so one has to be written twice, then 63, then 64. And make sure you count up all of your leaves here, because they must add up to 20. So this is 6, 8, 11, 16, and 20. So I've listed, I have all my data values accounted for. So that is my stem and leaf plot for that data set. So now we're going to use that to answer part B. Are more employees in their 40s or in their 50s? Well, these are the 40s and these are the 50s. There are more people in their 50s than there are in their 40s. Okay, so to answer part B, there are more in the 50s than they are in the 40s. Okay. Now part C, how many employees are younger than 30 years old? Okay. Younger than 30. Well, these are the 30s. There are 6 data values that are under 30 years old. So answer there would just be 6. And then part D, what percentage of the people are 50 years or older? 50 years or older. In this case here, we have to count the data values for the 50s and the 60s. Here there are 9 people that are 50 years or older. So that means we have 9. We have to divide that by the 20 data values that we have. And they ask for the percent. So that means we need to multiply that by 100%. So if I do 9 divided by 20 times 100, that will give me 45%. So 45% of the people are 50 years or older. Okay. So that's how we answer problem number 15. All right, number 16. Is a bar graph for this data. 5 coins are tossed 68 times. The distribution for the number of heads obtained is shown in the following table. Draw a bar graph for the data. So here we have the number of heads here, the frequency for each one of those. For each one of those, for that table, we want to construct a bar graph. So here is how we construct a bar graph. We need a vertical axis and a horizontal axis, like this. Let's see, this is from 2 to 20. So I'm going to do this vertical axis in increments of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And the horizontal axis, I'm going to have this 0, 1, 2, 3, 4, and 5. All right, so by using this here, for 0 heads, there are 2. So that means the height of the bar will be 2. I was hoping to use a different color, but they. All right, so at 2, that's going to be here because the height of the bar will be at 2. And then for one head, it will be 10. So the height would be at 10. So here's 10 up here. And then for 2, that's 20. Okay. So here's 20 up here. So I'm going to draw a line up here at 2. And then for 3, 3 was 19. That's halfway between 18 and 20. So I'm going to put it about right here. Draw the line there. I'm going to draw coming down this way. And then for 4, it's 11, which is halfway between 10 and 12. And then finally, a roll of 5, there were 3 heads. Number of heads was 5, that frequency was 3. Halfway between 2 and 4. So this is what the bar graph looks like for that data. Okay. So that's problem number 16. All right, number 17. If a trend line had the equation y equals 3x plus 6, what y value would you expect to obtain when x has the following values? Okay, so starting with a equal -2. Is part A. And in this case, x will be equal to -2. That would mean y is equal to, and our equation was y equal 3x plus 6. So it'll be 3 times x, which is -2 plus 6. 3 times -2 is -6. -6 plus 6 is 0. And then part B had the number 14, which means x is equal to 14. That will mean y is equal to 3 times, and maybe I need to write the equation y equal 3x plus 6 on top, so you'll know what I'm referring to. So here I'm going to substitute the x with 14, so it'll be 3 times 14 plus 6. 3 times 14 will be 42 plus 6. That adds up to 48. And then part C was 0. So that means x is equal to 0. That would mean y is equal to 3 times 0 plus 6. So 3 times 0 is 0 plus 6 would be equal to 6. And finally, part D had 6. So that means x is equal to 6. So that means y is equal to 3 times 6 plus 6, or 18 plus 6, which is 24. Okay. So that's how you find the expected value when you're given for a trend line when X has those following values. Okay, be on the lookout for part 2 of this review for the final exam. Okay, I'll talk about the remaining problems that are similar to what will be on the final exam. So be on the lookout for part 2.